In this lesson, we're going to have a look at how you can categorize different patterns or different sequences. When we say categorize, we mean you have a look at the pattern and put it into its proper category or state what type of pattern or sequence you have. Now, over the last number of lessons, we've been looking at linear sequences, or another name for linear is arithmetic sequences. It doesn't matter which name you give them. And so we're familiar with linear or arithmetic sequences. And we can identify a linear sequence because the first difference is always constant. So the difference between the terms is constant. So that's an easy one to categorize. There are other types of patterns that you might be asked to categorize, and I'm going to go through them now with you. So if we take a look at the first one here in our example, and let's do an examination of what is happening as we move from term to term. So 14 to 10, that's down 4 again from 10 to 6, down 4 again from 6 to 2. So as we can see here, the difference between each term is constant. The difference between each term is the same. And so this is a linear or arithmetic sequence. And you have to explain why. And the explanation, the neatest and quickest explanation you can give is to say that the first difference is constant. And this is literally the minimum number of words you can get away with. So that one is pretty familiar. Let's have a look at B. So this is the sequence given in B. So let's have an examination here of this sequence. So from 14 to 15, that's an increase of 1. From 15 to 21, an increase of 6. And from 21 to 32, an increase of 11. Now it's very obvious straight away that that is not linear because those differences are not the same. However, if you have a look at the differences follow a linear pattern. So if we have a look at the differences from +1 to +6, that's +5, and from +6 to +11, that's +5. So the differences form a linear pattern. So the original pattern that we were given is not linear, but it is a particular kind of addition pattern called a quadratic pattern. So this is a quadratic pattern because the differences follow a linear pattern. And the way we say that is the second difference is constant. So I've shown my work here with my +1, +6, +11 and the +5s, and I'm giving my explanation. And this is the minimum that's required. So there's one more, and again you would have met this in first year, but we're going to examine it here again. And here's the pattern 3, 6, 12, 24. Okay, now you might recognize it straight away, but in case you don't, let's just have a look at how you could do an examination of this. So if we look at the differences, okay, it's not linear for sure. And because the differences don't follow a linear pattern, it's not quadratic either. So it's not linear and it's not quadratic. So let's go back to the pattern again and look again at the pattern as we move from term to term. So I'm hoping you notice that as we move from term to term, there's no pattern in addition, but there is a multiplication pattern, because to move from term to term, we would always multiply by 2. A multiplication pattern is called an exponential pattern. Exponential pattern. Each term here is multiplied by 2. So those are the 3 kind of patterns you could have to categorize. So you'd have to examine the patterns and see what type of pattern you've been given. Linear, where the first difference is constant. Quadratic, where the second difference is constant. Or exponential, where none of the differences are constant, but it follows a multiplication pattern. So let's have a look at another example. And this time we're going to look a little bit more closely at quadratic patterns or quadratic sequences. So there's 2 given here, and I'm going to take them one at a time. So the first one is 2, 5, 12, 23, and it continues on. Now they want 3 things: the start term, the second difference, and the next 3 terms. So I'm going to go through all of those now. So it's obvious, I think, the start term is 2. Often we call the start term A. Yeah, so the start term is often labeled A. Let's do an examination of our pattern here. So first difference is 3, 7, and 11. And now the second differences are 4. Now they told us it was a quadratic sequence. So we were expecting the second differences to be constant. Okay, so the second difference, often called D, is 4. And now they want us to continue this pattern and produce the next 3 terms. So in order to produce the next 3 terms, we're first going to have to continue the pattern of the differences. So the differences were 3, 7, 11. The next difference would be 15. The next one, 19. The next one, 23. So I'm just continuing the pattern here of the differences. So now I can add on those differences to get the next number of terms. So from 23 I need to add 15. That is 38. From 38 I need to add 19. That will take me to 57. And from 57 I need to add 23, and that would take me to 80. So that's all 3 questions answered. Let's have another look at that. So minus 1, 2, 0, minus 7. That's the pattern we're given. So let's do an examination of that. So from minus 1 to 2, we add 3. From 2 to 0, subtract 2, and from 0 to minus 7 we subtract 7. Here are the first differences. So what about the second difference? Well, from 3 to minus 2 we subtract 5, and from minus 2 to minus 7 we subtract 5 again. So the second difference, or the pattern in the differences, is minus 5. So what's the start term here? The start term, often called A, is minus 1. And the second difference is -5. And now we need to continue our pattern to find the next 3 terms. So in order to do that, we first have to continue the pattern of the differences. So the differences that we have so far are +3, -2, -7. So they're going down 5 each time. So the next difference will be -12, the next one -17, and the next one -22. And that allows us to continue the pattern. So from -7, we need to go down 12. That's -19. From -19, we need to go down 17, -36. And from -36, we need to go down 22, -58. Okay? And so then just one more example then of an exponential sequence. Here we have an exponential sequence 7, 21, 63, 189. We want to show it's exponential. That just means we need to show it's a multiplication pattern. And so you can see there, to move from term to term, we need to multiply by 3 each time. Okay, so it is exponential. As each term is multiplied by 3. And then we need to continue the next 3 terms. And so just use your calculator to help you here. So to get the next one, we'd need to multiply 189 by 3, which gives me 567. Multiply by 3 again, 1701. And multiply by 3 again, 5103. And so those are the next 3 terms of the exponential pattern.